Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, as we know that the population may be very large or even infinite. In many cases, it will be impossible or impractical to find the value of the population mean mu or the value of population standard deviation sigma or variance. However, we can find an interval which can assure us that the value of population mean mu is inside that interval, or the value of variance sigma square is inside that interval. Such interval is called confidence interval. In this video, we shall study different cases. Let us start from the first one. 95% confidence interval for mu when the population standard deviation sigma is known is given by this formula: x bar minus 1.96 sigma over under root n, and this is the same thing, just we replace this minus by plus. Here x bar is the sample mean, which can be obtained by using this formula. N is the size of the sample and sigma is the population standard deviation. To prove this formula, we want to find probability of z between minus 1.96 and 1.96. We take these two numbers from here and here. And now z is a normal distribution, so it is equal to pi of b minus pi of a. But pi of minus a, we know that it is equal to 1 minus pi of a. So using that rule, we get this thing. Now if we simplify this, we get 2 pi of 1.96 minus 1. And now we can use the table of normal distribution to find the value of pi of 1.96, which is 0.9750. If we simplify this, we get 0.95, which is equal to 95%. Hence the probability that z is between this number and this number is 95%. In the next step, we substitute the value of z given by x bar minus mu over sigma over under root n. We substitute it here and then we multiply each inequality to eliminate this term from the denominator, and we get this thing. In the next step, we subtract x bar from each inequality and we get this one. Now we multiply each inequality with minus, so the inequality will change. When we multiply this with minus, it will become plus, this will become plus, this one is plus and this one is minus, and the inequality has been changed. This can also be written as probability of this term is less than or equal to mu, which is less than or equal to this one, is equal to 95%. And that is the proof. It shows that there are 95% chances that the value of mu is between this number and this number. Or we can write that the confidence interval is equal to this number and this number, which is 95% confidence interval when sigma is known. Let us use this formula to solve an example. A random sample of size 100 and mean 21.6 is taken from a population with standard deviation 5.1. Construct 95% confidence interval for population mean mu. Here we are given that n is equal to 100, x bar is equal to 21.6 and sigma is 5.1. Formula for 95% confidence interval when sigma is known is given by this one. Just we need to substitute the values of x bar, sigma and n and then use calculator to simplify this. We get the interval 20.6 comma 22.6. This implies that there are 95% chances that the value of population mean mu is between this interval. Let us generalize this result, which means that if someone asks us to find 92% confidence interval for mu or 99% confidence interval for mu with known sigma, then we can use this general formula to find the confidence interval for mu. Here we don't give the proof. The proof is very similar, just like we have proved the first one, but we shall focus on the use of these formulas. X bar is sample mean, n is sample size, sigma is standard deviation of population. But an important thing here is that if someone asks us to find 20% confidence interval, then we shall put 1 minus alpha is equal to 20%, which is equal to 0.20. And then we shall simplify this to find the value of alpha and alpha by 2, using the value of alpha by 2 here, and then by the table of normal distribution, we can find the value of z. Even if someone asks to find 99% confidence interval for mu with known sigma, then we shall substitute 1 minus alpha is equal to 99%, which is equal to 0.99. From that we can get the value of alpha and then alpha by 2. Using the value of alpha by 2 here, from the table of normal distribution, we can find the value of z. With the help of this procedure, we can also find the error in this procedure by using this formula. Error is equal to z alpha by 2 into sigma over under root n. We can also find the size of the sample by using this formula. N is equal to z alpha by 2 into sigma over e whole square. Sometime we will be asked to find only the upper bound. Then the upper bound can be obtained by x bar plus z alpha into sigma over under root n. Just note that here we have alpha, not alpha by 2. Similarly, if someone asks to find upper confidence interval, then we have to use this formula. And to find the lower bound, we can use x bar minus z alpha sigma over under root n. Just plus is replaced with minus. And in a similar procedure, we can find lower confidence interval, which is given by x bar minus z alpha sigma over under root n. And there is no restriction on the upper value of this interval. Let us solve this example. The average zinc concentration recovered from a sample of zinc measurements in 36 different locations is found to be 2.6 gram per milliliter. Assume that the population standard deviation is 0.3. Find 99% confidence interval for the mean zinc concentration in the river. Here we are given that n is equal to 36, x bar is equal to 2.6, sigma is equal to 0.3. And we need to find 99% confidence interval. So just like we have studied, we shall substitute 1 minus alpha equal to 99%, which is equal to 0.99. Simplifying this, we can get the value of alpha and then alpha by 2. And now just substitute the alpha by 2 here. We get z 0.005. From the table of normal distribution, we get the value which is 2.575. The last step is to use this formula and substitute the values. After simplification, we get 2.5, 2.7. Hence, we are 99% confident that mu belongs to this interval. The value of mu is greater than 2.5 and is less than 2.7. Let us solve another example. How large sample is required? So we need the value of n. If we want to be 95% confident that our estimate of mu gives less than 5% error, let sigma is equal to 0.3. Here error is given, which is 5% equal to 0.05. Sigma is 0.3. And we need 95% confidence. So put 1 minus alpha is equal to 95%, which is equal to 0.95. From this, get the value of alpha and then alpha by 2. Substitute that value here and we get Z 0.025. From the table of normal distribution, we get the value which is 1.96. Now just put values in this formula and simplify this. So we get the solution that n is equal to 138. Let us study another case when sigma is unknown and n is greater than or equal to 30. We will see that all these formulas are very similar to each other, just like the confidence interval for mu with unknown sigma and n greater than or equal to 30 is given by this one. Here we only replace sigma by s and the remaining formula is same. Here to find the value of s, this is sample standard deviation, we use this formula. In a similar procedure, we can find the error and sample size. And as compared to the previous case, we just replace sigma by s. To find the upper bound and upper confidence interval, formula is same just like the previous case. We are replacing just sigma by s. And lower bound and lower confidence interval, that is also the same, just replace sigma by s. This is another case when sigma is unknown and n is less than 30. Formula is very similar to the previous case, but instead of normal distribution, here we use t distribution, and the value of this can be obtained by using t table. Here x bar, s, and they are same, and to find the value of alpha we have to put 1 minus alpha is equal to the required percentage which will be given in the question. This n minus 1 is called degree of freedom. It is needed in the table of t distribution. The error and sample size can be obtained by using similar formulas. Just instead of z, we use the value of t here. Similarly, to find the upper bound and upper confidence interval, instead of z, we use t here. And we can find the lower bound and lower confidence interval by using similar formulas by replacing z by t distribution. Example number 4. The amount of 7 similar containers of sulfuric acid are given by these numbers. If the distribution is assumed to be approximately normal, then find 95% confidence interval for the population mean mu of such containers. Here we are given that n is equal to 7, and to find x bar we have to add all these 7 values and divide it by 7, we get 10. To find the value of s, we use this formula, and after simplification we get s is equal to 0.3. 28. Now here we need 95% confidence interval. So we substitute 1 minus alpha is equal to 95%, which is equal to 0.95. If we simplify this, we get the value of alpha, and from this we get the value of alpha by 2. Now, from the table of t distribution, we can obtain the value of t 0.025, comma 6, which I will show you at the end that this value is 2.447. Finally, we use our formula for the confidence interval, substitute the values and simplify this. We get that the interval is 9.7, comma 10.3. So we are 95% confident that the value of mu is greater than 9.7 and less than 10.3. Let us study this last case. For the confidence interval of population variance sigma square, which can be obtained by using this formula. Here, this notation, which is called chi-square, its value can be obtained by a special table known as the table of chi-square distribution. And we know that here S square is the variance of sample, N is the sample size, and to find the value of alpha by 2, we shall substitute 1 minus alpha equal to the required percentage, which will be given in the question. N minus 1 is degree of freedom, which will be needed in the table of chi-square distribution. Upper bound for sigma square is very simple. Just we have to replace alpha by 2 with alpha. And similarly, to find the lower bound, we have to replace alpha by 2 by alpha. Now let us solve an example. A manufacturer of the car batteries claims that his batteries will last an average 3 years with variance of 1 year. If 5 of these batteries have lifetimes of these years, construct 90% confidence interval for sigma square and decide whether the manufacturer claim is valid or not. Assume the population of batteries lives is normally distributed. Here n is given, which is 5. These are 5 numbers. To find the value of sample mean x bar, we add all the given values and divide it by 5 to get x bar is equal to 3. To find the value of S square, we use this formula, and after simplification we get that its value is 0.815. As we are required to construct 90% confidence interval, so we put 1 minus alpha is equal to 90%, which is equal to 0.90. After simplification, we get the value of alpha and then the value of alpha by 2. Now we also need the value of 1 minus alpha by 2, which is 0.95 after simplification. Now, by using the chi-square distribution table, we can obtain the value of chi-square 0.95, comma 4, which is 0.711. I will show you this value at the end. Similarly, the value of chi-square alpha by 2, comma n minus 1 is 9.488. Finally, we use our formula and substitute the values. After simplification, we get the confidence interval for sigma square. Hence, there are 90% chances that sigma square is inside this interval. And the claim that sigma square is equal to 1, we can see it is inside our interval, so the claim is true. In example number 2 and in example number 3, we have used this table to find the values. In example number 2, we have obtained the value of Z 0.005, which is 2.58. And in example number 3, we have obtained the value of Z 0.025, which is 1.96. You can find this table in the book Advanced Engineering Mathematics by Crazy, or just take a screenshot and save this table. In example number 4, we have used the table of t distribution. We have found the value of t 0.025, comma 6. So we find the intersection of these two numbers, which is 2.447. You can find this table from the same book or from the Google. In example number 5, we have used this table of chi-square distribution. To find the value of chi-square 0.95, comma 4, we find the intersection of these two numbers, and the answer is 0.71. The next value which we have obtained is 0.05, chi-square 0.05, comma 4. Again, we find the intersection of these two numbers and we get 9.488. That's all.